Aloha, Richard Halverson here. This is ICS211, and today I'm going to do lab number 5, the Heap Sort project. So let me share my screen. And so in this project, we're going to take what we did for lab number 3, which was the comparison of the merge sort and insertion sort. And we're just going to take that, make a copy of it, and then add heap sort to it. And then we're going to do one little other minor thing. We're going to add a swap count and a comparison count, just like we had for the other ones. And we'll see what that looks like. And we should see that heap sort behaves much more like merge sort than insertion sort. So let's get started here. So I opened up my Eclipse, and I'm going to start with, let me just create a new Java project called Heap Sort Comparison. How's that? Heap Sort Comparison. And then I'm going to create a package called the same. And then I'm going to create a new class. No, is that what I'm going to do? Oops, I didn't do that. Yeah, just the same. A new class, let's see. New class called, I'm going to call it sort comparison. All right. So now I'm going to go over to my old sort comparison. And I'm going to take this whole thing. Why not? I'm going to take this whole thing. All right, and I'm going to go over to, I'm going to close it and go back over this one, and I'm just going to paste it right here. Okay. And then I think I should probably run it to make sure that it works. This is not the one I want to run. Let me close this up. It's this one. And it asks for the number of elements in an array followed by an array. So I'm going to give it this one, 32. 32 space paste, enter. And we have insertion sort comparisons and insertion sort swaps and merge sort comparisons. And I guess what we are asking for is add code to all 3 sort methods that count both comparisons and swaps. Use your best guess when deciding what qualifies as a comparison and what qualifies as a swap. For example, merge sort doesn't really have swaps, but it does a lot of copying, back and forth. So you maybe can count those as swaps. In heap sort, there's definitely swaps because nodes are sort of trading places, going up and down the tree. So, all right. So we have this, we're printing out the array, insertion sort, merge sort, and let's add, I guess let's add heap sort. So I'm going to go over to here and go to, I guess it's in 20.5.1. 20, yeah, here we go, 20.5.1. And it's this whole thing. And so I'm just going to copy, I don't need to copy that, but I can copy like from here down to here. This is the main. So let me copy this. And I'm going to go over here, and someplace I'm going to put, this is reading the numbers, this is printing the numbers, this is swapping, this is insertion sort, merge sort, static void main. So I'm going to put it right here. Put a paste, Control V, and here it is. I'm going to select all and correct the indentation. Okay. So this is heap sort, and it brings in some numbers, just like merge sort brings in some numbers, but also has a high and a low, I guess. Okay, and then insertion sort is just an integer array of numbers. Okay, so insertion sort is like heap sort, it looks like. So let's go down here. And we have this, you remember, this is the original set of numbers, and then this copies the original set of numbers into an array called numbers, and we print it out, and we display it, we insertion sort it, and then we print it out, and then we print out the number of comparisons and swaps, and then we start again. We copy all of the originals into numbers, the original array again. We set comparisons equal to 0. We better set swaps equal to 0 too, because we're gonna have to figure out something to that. Swaps. And then print out the numbers, merge sort it, print out the sorted numbers, and then print out the comparisons and the swaps. What do we say for swaps? Comparisons and swaps. So I'm going to copy paste this. We got to figure out something for swaps, or sort of swaps and swaps. And then I'm going to do the same thing. I might as well just copy. I like this right here. Except for I'm going to replace insertion with merge sort. Okay, copy, put on here, paste, and this is going to be this is merge sort, and now we're going to start with heap. Print numbers and then say heap sort and heap sort. And I needed to set these. I needed to do this. All right. All right, I'm just gonna run this right now to see what it looks like. So I'm gonna run this one. And so the array, what's a good array? Here's a good array. Copy. This is a 32. 32 space paste. Insertion sort comparison swaps, merge sort comparisons swaps, and heap sort comparison swaps. It looks like they sort. Oh, fine. I'm going to put something in front of this. I'm going to make this a little bit more uniform. Let's see, insertions, so print numbers. Let's see. Um, I'm going to take merge sorts. I'm going to take this out. I'm going to put a title up here. System out print line insertion sort. And so that'll put that up there. I'm gonna put a space there, so that'll print out right here. Then that'll print out just like that. Then merge sort. That is this. Oh, I see what I do. So I can go. This is insertion sort. Unsorted. And then this is this goes out, this goes here. And this can go sorted, sorted. And I want this to be sorted, and this can be and it's heap. All right, let's see what this looks like. Copy, paste. Oh no, I have to do the 32 first. Darn it! Oh, shoots. Run this again. You know why it always shows the last one? 32 space paste, enter. And we have insertion sort, comparison swaps, merge sort, comparisons nothing, heap sort, comparisons nothing. I want to get rid of that space for this merge sort comparisons. I guess that's right here. I want to get rid of this. Insertion sort. What happened there? Unsorted. This should go here. Okay, so now let's figure out where we put the swaps and the counts. So we need to put some swaps in merge sort, and merge sort is okay, here's merge sort. And what we're doing here is we are going through the numbers. There's like a left list and a right list. And if the number on the left is less than the number on the right, then we take the number on the left and increment that index, or if it's not the case, we take the number on the right and increment that index, and then we increment the index, which the index of the destination array. This is taking this is taking arrays. This is taking numbers out of this array and putting them into this array. And it's alternating between left and right depending on which one is smaller. So anyway, so I would count this whole thing as one swap. It's either the swap is going to come from here or come from here. So I'm going to increment the swaps. And this increments the comparisons. And this actually finishes up the swaps. So I'm going to put this here, and this finishes up the swaps. So this is going to run until one side runs out. And then if the left side runs out, then this is going to grab up the rest of the if the left side runs out, this is going to grab up the rest of the right side. If the right side runs out, it's going to grab the rest of the left side. So those are these. So I can kind of count swaps that way. So now let's look in heap. So with heap, we're gonna we set them equal to 0 down here before we run it. We set them both equal to 0, and then we run the heap sort here. And see, this is here we're swapping. Here we are actually swapping. So I'm gonna increment swaps here, and here is a comparison. Yes, here's a comparison. Let's see. Yeah, that's more or less where I thought it should go. And I had swaps in another place too. I guess I had swaps. Oh, here. Yeah, this is a swap also. We're swapping here too, and I didn't count it. So swaps. All right, well, that might be good enough. Let me run this. And let me try running it with 8. Copy. So I'm going to try 8 space paste, enter. And it looks like comparisons, insertion 17, 17, 24. Okay, so swap 16, 24, 18. Okay, whatever. And let's tell you what I'm going to clip this. New. And I'm going to just copy this. And set this aside. And I'm going to go, I'm going to run this again. This time I'm going to do 32, which is this one. I'm going to get a new set of 32. There we go. Copy. And that's going to be 32 space paste, enter. And this has gone up to 276, whereas this is 123. This is also doubled. This is 32. So let me I'm going to save this somehow on the desktop. I'm going to call it Heap 8. This is Heap 8, and this one is Heap 32. Excuse me. I'm going to save this as. No, this is, what am I doing? I'm doing this wrong. I need a new, and I'm saving this as Heap. This is Heap 32. I'll make sure I get the 32 there. And so I'll copy this and I'll save this as Heap 32. And then let me go to run this again. And this time I'm going to grab 128. Copy. And this is 128. Space, paste, enter. And now we have insertion sort went up to 4,000. And merge sort is down in the around less than 1,000. This is a little over 1,000. The swaps are about the same. These swaps are way up. So you can kind of see that the heap sort behaves a little more like insertion. Heap sort behaves more like merge sort, and insertion sort grows much faster. And so what you have to do now is the same thing that you did for video 3. You can go back and look at the video 3 video if you'd like, the lab 3 video. And basically you make a video of you're running this 3 times with these 3 sets of data, and that's what you upload here. So anyway, I hope this helps. Thanks for watching.